Let's get started. Hello and welcome to our last webinar for this year. So today for our new release, Lockup 5.5. Today we actually have the title Center of Gravity Analysis, now two-phased. And actually the reason for this is we have two calculation methods in the center of gravity methods that we want to present you today. And we also have a couple of other topics, already a small preview. The session today is actually maybe a bit shorter because we have a really big release coming up, Lockup 6.0 for next year in February, where we are already really excited and the whole dev team is already full speed working on this one. But I also think in the Lockup 5.5, we also brought you some helpful new features that I actually want to present to you today. Let me directly go to the agenda. So we have actually three items what I wanted to show you today. Before I get started, like always in the webinar, you have the possibility to ask your questions in this Q&A section, and we will directly try to answer it in the background. If we have some interesting questions for the whole audience, we will also take this up. So feel free to ask questions. It's always helpful to explain them then in more detail for everyone. Yes, so the three items what I actually wanted to show you today is actually the first one, like the title already mentions, we have something new in the center of gravity. We have actually two calculation methods. One calculation method is still the default one. This is how we had it the whole time. And then we actually, this is the optimization based on weighted distance. And we have another calculation method. This is actually the more traditional way how to calculate the center of gravity, but I will go in detail. What is the difference between both calculation methods? Yes, and how you can select each of them. The next topic what I wanted to talk about is the Transport Optimization Plus. In our last webinar, I talked already about a cost allocation in the Milk Run Optimization Plus. And now in this release, we also offer the same feature now in the Transport Optimization Plus. Here, the calculation is slightly different than in the Milk Run Optimization Plus, and I will show you how the calculation itself is done. Then one additional often requested features from our custom was to redesign a bit the workspace area to support, for example, subfolders, drag and drop, and so on, that it's just easier for you, that you can actually manage your workspace, especially when you work on bigger projects. You can have many items in the workspace. And here we hopefully help that you can organize it easier for you with some subfolders. This is the topic what I wanted to show at the end. And then, yes, let's directly jump into the tool and take a look at the new features. So this, let me exit quick the presentation and go to the Lockup platform itself. So like always, let's do as a first step, quickly go on the platform and let's create a new workspace that we will use during this webinar. So we have Lockup 5.5. Let's create this one, and then we can directly go back and take a look at the center of gravity method. So before I directly jump in our extreme example, let's quickly open the regular center of gravity application with our sample data. So just to recap, center of gravity, we have customers, and each of these customers, so here in the address-based approach, are assigned a weight. And according, so how many centers I want to calculate, we are calculating then the center position and also the assignment. So here I just calculated one center. Let's directly do the same. I forgot because we need later for the drag and drop some sample data. Let's directly save this on the platform too. I selected the workspace that we created, the Lockup 5.5, and let's do the center of gravity in here. And let's quickly take a look. So this is the default result of our center of gravity. We have here the blue guys. These are our customers. They are actually sized depending on the weight. And then we have actually our center. The center is then positioned depending on the weighted distance. This means if I have a sender with a huge weight somewhere in the north, this would pull my sender calculation more to the north. So it's not only on the amount of senders dependent, it's also dependent on the weight that is actually assigned to a certain sender. To make actually the calculation difference more clearer, let's go to one extreme example so that I prepared. So what I did, I really just took the first two rows of our sample data. And what else I did, I assigned the first customer a weight of 2 and the second customer weight of 1, right? So quite a simple example, but there it actually gets really easy visible what the difference between both calculation methods are. But let's first take a look what is at all difference here in the application. The only thing that is different, we have an additional parameter, minimize distances. So by default, this is set to on. And this is actually the calculation how it was the whole time. This means if you calculate now a center of gravity and you don't change this parameter, everything will be like before, because we optimized already before based on the weighted distance. So just that you have an idea what we are doing here, if this feature is on or like it was the whole time, we always did internally under the hood a second optimization step that is actually minimized in a separate step the weighted distance. And if we turn this off, then this additional optimization step that actually generates better result, and I also will show you this, that the result is actually better than, this will be turned off, this additional step. But let's just take this calculation and take a look actually at the map, how it looks like. So let's just rename this because now we have this feature on. And we calculate now the center of gravity just with these two customers. And let's take a look at the map. What is actually happening? Let me switch quickly to the dark mode. What is actually happening? I only see 2 points. And here I can see, okay, the yellow dot is directly on top. If I open here now on the right side, I can see that our center is directly placed on top of one of the customers, right? This is the current result of the optimization. So here we have the center and we have the customer with the weight 2. This means the optimizer decided, okay, it is most efficient, depending on optimizers on the weighted distances, to place the center directly on top of the customer. And let's take a look. Let's directly prepare this for the other one. I just first want to show you the effect actually visually. But what I did do additionally, I just export here the assignment and the sender. I will need this later that I can explain you in detail and the difference between the two calculation methods. Now let's do the same thing and say, okay, I want to have now this feature off, the minimizing on the weighted distance. Let's do the calculation. Let's take now a look at our map. Also switch quickly to the dark mode. And now we have actually one point here. It's bigger. It's the one that we had before, right? Is one customer with the weight of 2, one customer here with weight of 1. And now we place actually the center somewhere in the middle, but it's pulled more towards the bigger center. So if we take a look now at the map itself, so from a geographical perspective, this result looks actually better than the other one, just from a geographical logical perspective. If we take but a look now at the number, at the real results of the optimization, I will show you that the other result is actually the better one. And now why we brought this feature in, because we had a couple of times some customer, they asked, hey, why is the sender now not placed here? From a visual perspective, logically, this would be better. So we displayed the whole time the better result, but now you have the options to use actually both methods. Let's quickly take a look. Why is the first result actually the more optimized when we optimize on the weighted distance? Let's also export here now the result. So our optimization function is, like I mentioned the whole time, is the weighted distance. This means here we have the distance from the sender itself to the customer. Because in this first example, we place it directly on top of the customer, we have here a distance of 0, right? And here we have then a higher distance of 1,523 kilometers. Let's take a look. Weighted distance means we multiply the distance with the weight. This is our weighted distance. If we take now here, for example, the sum, we have in this example, we have a weighted distance of 1,523. So this is our target function in the first optimization methods to minimize this one. Let's take a look at the second example. Here, we take the distance, what is around 500 kilometers. And the other part is a longer distance, it's more about 1,000. But now here, we have actually a much higher, so it's also an extreme example, right? With these two customers, we have a higher weighted distance of 2,025. So here you can see that even if geographically, the second example looks maybe a bit more logical to place the sender here. You can see if it's optimized based on the weighted distance, the first result is much better. So and now you have the possibility to activate and to turn this feature on and turn this feature off. So for all of the customer who asked us already in the past, we had in the past a separate center of gravity that we opened then for some of our customers where you could use actually this additional approach already before, but now you have the possibility to just turn this feature off to actually use the other calculation method. So now you have the possibility to use actually both. If you don't change this parameter at all, the calculation will be like before. So, and this is the topic that we have now, the center of gravity method with two calculation methods. And just to mention this one, it's not only in the center of gravity, it's also here in the center of gravity plus. And we also have it in the fixed center of gravity. So in all the regular center of gravity apps, this feature is actually available and you can turn it on and off. Okay, perfect. So this was actually the first part, what I wanted to show. Maybe a quick question to the team in the background. Are there any questions that I have to take up or can I continue?
No, at the moment we don't have questions.
Okay,
No.
perfect.
Nothing so far.
Good, great. Then we can directly jump into the next example that I wanted to show you. This is actually the cost allocation in the Transport Optimization Plus app. In the Transport Optimization Plus, we support this feature already with the cost allocation, the Milk Run Optimization Plus. For all of you who joined our last webinar, you saw the detailed explanation, and now we also have it in the Transport Optimization Plus. Let me take a quick look what is actually happening here and how does this cost allocation actually work. Therefore, I go to the Transport Optimization Plus, and I prepared here already a slightly adjusted or let's say it like this, I made a bit more easier example than our sample data application, because what I did, I used actually one vehicle. Before we directly go in the cost calculation allocation topic, I quickly want to explain the difference between the Transport Optimization Plus and the Milk Run Optimization Plus. So in general, it's the same optimization engine in the background, but the input data is different. So in both applications, you are defining the vehicles like we did here. Here we have one vehicle and it has a starting depot in Zurich here. And then you can define, for example, here, this is also relevant for this topic, besides the restrictions like maximum weight, volume, and pallets. Here only pallets are relevant for the input data. You can also define actually the costs. So you have the possibility to define a fixed cost. This means when one vehicle is used, then it costs 200 units, and this time in our country is Swiss francs. And then you have costs per hour, per kilometer, per stop. And based on these parameters, we actually assign then in the output the result, how much costs this truck for you, okay? And let's take a quick look. I will also run it through, then we can take a look at the optimization result. And what is important here in the transport optimization, the inputs are actually shipments. So we have shipments from a certain location to a certain location, from a certain location to a certain location. And these shipments can be totally independent from each other. And there is actually the difference to the Milcron optimization plus. In the Milcron optimization plus, the optimization target is you have one depot, there are all your goods. And either you need to deliver all the goods from the depot to these places, to the customers, or you have to pick up something from the customers and bring it back to the depot. Here in the transport optimization plus, it's really like random shipments from point A to B, from C to D, and so on. So they can be totally independent from each other, but still the optimization target, and let's take a look quickly on the result on the map, is to build actually routes. How can I combine all the shipments together that I need, that I can reach the lowest cost, right? And therefore, to do these shipments, what you just saw, we need actually 7 routes. So 7 routes are actually in this, then also 7 trucks. And for this example, I want to take a look at the route number 1. So here in the route number 1, in total, we see here around 8 stops, because here is 1 and 8. This here is actually, let me activate the interactive one. This here is actually the starting depot in Zurich. This means the truck starts here empty and is driving to his first stop. This is the number 2. And here he actually does a pickup of 10 pallets. Then he is driving to an additional stop, does another pickup from 9 pallets. And then he goes to number 4, does again a pickup of 3 pallets. And then here to number 5. And here we actually delivering the first pallets, this 9 that we actually picked up here. So even if we see here actually 8 different stops, in total we are transporting on this route 3 different shipments. And these are here the shipments from number 3 to number 5. These are the 9 pallets. From number 2, we have the 10. Let me try to find them. Yeah, here is the 10. So from Aarburg to Bischofszell, this is an additional shipment. And here, this direction to here to the 7 is also an additional shipment. So this is actually the result of our output. And now we need to allocate actually the costs to the shipments itself or to the separate stop of the total route. And let me quickly show you how we actually do this. Therefore, I prepared here something in the output. Before I jump to this, I mention the cost allocation here. You have multiple methods to assign the cost. You can assign the cost only based on the weight, on the volume, on the pallets, or on the combination of the 3 of them. Right? I had by default, this is the combination of the 3 of them, but I have to say, if you take a look at my calculation, I only used pallets in my optimization, right? This result is exactly the same result like you would select here pallets. So you have the possibility to select under which criteria you are actually using for the cost distribution. But let's take a look how the costs are actually distributed. And therefore, I prepared here our output sheet. In the output sheet, you get all the 7 routes. And what you had already the whole time, you had the costs. So by accident, the costs are here exactly 1,000 for this route. So this is the first route that I just showed you on the map. The second route would have a cost of 1,272. So these are the costs of the first route. These are the one that I want to actually distribute. Then let's go back to the route itself. Here I did nothing else than filtering on the route details on the route number 1. And here we can see the exact same sequence that I showed you already on the map. Let me quickly highlight this. So in the first topic, so from Zurich, we drove empty to this Aarburg, and there we did the first pickup. And here in the back, you can also see we picked up 10 pallets, then 9, then 3. And then we delivered 9, 10, and 3. So these are the stops that are actually involved in this optimization topic. Now, how do we actually distribute the cost? What is actually new is these columns that we exactly show you how much cost each of these stops are carrying. And if you take a closer look at the cost, you can see that the costs always of 2 of them are identical. This is the reason, because this is one shipment. We make a pickup in Aarburg, and delivering it to Bischofszell, right? The next one here is a Beromünster that we drive to Einsiedeln. So these two are the same because we calculate actually the stops, how much cost it needs to carry, then we add it together, and then we divide it by 2. That actually the shipment is split up depending on these locations. This we will see now in detail. And therefore, what I did, I distribute the cost actually depending on the distance that to the starting location. So therefore, I have again here this picture. So we are driving around, but now each of these stops have to carry actually a certain amount of costs. And these costs are depending on how much pallets are first of all delivered there and how far is actually each stop away from the starting location. So we take the starting location, at this time it was the depot in Zurich, and then we calculate this red line, how far are each single stop from the starting location. And this is actually done here with this distance matrix. So what I did, I take this table here until here, and then I went to the distance matrix. The distance matrix, I filled in exactly this topic, and the result is then here. Because it's a matrix, you need to read it like this. This line is relevant for us. This line means from the depot Zurich to Aarburg, it's exactly 57 kilometers, and here to the Beromünster topic. So this line here is exactly these red lines here. And this is what I did. I wrote them down here. Okay, the distance from the depot to the certain location is this one. And now we have to consider how many pallets are actually used. So if I would select weight, then I would do the same topic here with the weight instead of the pallets. Then I assign, okay, here we picked up 10, 9, 3, then we delivered 9, 10, 3. In total, this is a 44. Total of the pallets is here not relevant. But now we multiply the distance with the pallet and have then this result. And here it's relevant the total of this. So the weighted distance, you can say it. It's just calculated based on the pallets. If we would do it by the weight, we would multiply weight with the pallets. If we would do it with volume, we would multiply the distance with the volume. And then in the next step is we calculate the percentage. So here we just divide this 565 divided by the total 3,146, and then we get this percentage here. So the sum over the percentage, if we calculate it correctly, should be 1 again. And then we have to distribute now our total cost of 1,000. The total cost of 1,000 we find here on top in our route. These are the total costs. And if I multiply now the total costs of 1,000 with the percentage, that I get for the first stop a cost of 179.79, and for each of the stops. So if I compare now this number with these numbers here on top with the cost, then it's not the same number because there is one step missing. Because it's one shipment, this is actually also the reason why I highlighted directly the colors, right? The green one is one shipment, the yellow one is one shipment, and the gray one is one shipment. Because here in the next step, we take a look at the shipment from Aarburg to Bischofszell, has the cost part, the first one this here of around 180. And this one of around 280. And then these two cost part together is a total cost of 458. And this divided by 2 is now exactly the same number that we have here on top. So for each of the stops, we have 229. And this is assigned then here to the cost allocation here on top. Sorry, what? Yeah, here. So this is actually then the result, how the cost is actually distributed. This means we take of both legs the two cost parts together, divided by 2, and then we project it here on the costs of each of the stops. Okay, so a lot of calculations that are done. I just wanted to show it in detail, what is actually behind exactly these numbers. So for sure, you can use this cost distribution. If you would assign your cost in a different way, would be also not a problem. then you could also do the same in another calculation. But this is our standard approach, and so it's a quite logical approach to assign the costs like this. But if you would need a different calculation, you can also calculate it on your own. Okay, perfect.
Alex, in the meantime, a few questions also popped up. I tried to sort them a little bit. Also, a few of them are related to the center of gravity. Okay. Nevertheless, let's perhaps also start now with this cost redistribution. There's a question, which sources are used to calculate the shipping costs? And also, how often are they updated? Perhaps it would be good if you explain how costs are calculated and how to model them also, that we have that clarity.
Okay, so this is regarding the transport optimization, right? Yes. So I just ran it here again, that we have this later in our lockup 5.5 folder. Sorry, I forgot this in the beginning. Let's take a quick look how these costs are actually calculated. Therefore, I have to go to the input. So the optimization function is we have a certain vehicle fleet available. In this example, we have 20 vehicles of the exact same type, right? So they have all the same costs. They can carry the same amount of topics. If we take, for example, a look in the sample data, I just generated it again, you can see that here we have 3 vehicle types. Let me explain actually the costs on the 3 vehicle types. It makes actually more sense. So here the vehicle fleet, each vehicle has a certain cost. And this one is, you can define this like you want to have it on your own, right? You have these parameters. You have actually the fixed cost. This means whenever a vehicle is used, then it costs directly 200. If we use, for example, a small vehicle, we have a cost of 180. If you don't want to have a fixed cost at all, you can also say, hey, this truck, I anyways have it. I don't want to work here with a fixed cost. I only want to work with other cost elements. Then you have the possibility to assign a cost per hour, right? Often only some of these elements are actually used. We just want to show which options you have. For example, sometimes you have fixed costs, and then you say, okay, I don't want to assign a cost per hour, but I want to assign a cost per kilometer, right? For example, or it is also possible that you don't have, for example, at all a fixed cost and you only pay per kilometer. For example, if you have an external provider and you have a rate with him, okay, you pay 2 euros or Swiss francs per kilometer, independent of how much you drive, then this is the cost. Then here we have an additional cost element per stop. So this you could also theoretically set to 0. Depending now on this parameter, we first optimize the route, right? And the route, let's quickly go back to the map itself. So now here we have actually these 8 stops, but the first stops that are not calculated, we have actually 6 stops at customers. So if you would have configured costs per stop, you would have, for example, this 2 multiplied by 6. Plus then because the vehicle is used, you would have the fixed cost, plus you would have the cost for the blue line calculated actually on the street distance, right? Because the costs per the distance. If you have the cost per time, we would also take a look how much time it takes for the vehicle to do this job, and this also a cost parameter. And all this to sum up is actually then in the end the result of, sorry, give me 1 second. I need to find my output sheet. Here, this is actually then the result of the main route, right? Because one route is one vehicle. And this costs that you see here are calculated like I just described, or how you configure it. The topic was then, now you have a cost for a vehicle, but you had always the problem because one vehicle transports goods for multiple customers, and you want to assign then the costs on a shipment level actually back. And this is actually what we did here in the cost distribution. So, but here the costs are actually calculated, like I explained you, depending on your input parameter. Yep. I hope this explained the topic.
Perfect. Perfect. Thanks a lot, Alex, for that. Then there's the next one. So this is related to the center of gravity. How would the weight used for the center of gravity differ from demand? would it not be more appropriate to use demand as the weighting factor and minimize demand times distance instead?
Yeah.
Yeah.
Yes, I fully agree. It fully depends on your
sorry,
use
Alex,
case, right?
just to step in. These
Yeah.
maybe the teams didn't load properly because we also have some issues there, but these were also answered just in written. So the COG
Okay.
questions were already answered.
Okay, perfect. But Alex, perhaps you can comment
Yeah,
on
I
that
can
then.
just sum it up. I think it's
Yeah.
interesting for the whole audience. So there it is really like this. The center of gravity, yes, we write here weight, but it doesn't mean the weight of shipments. It could be exactly the demand. This column name weight is like a generic name. It could be a number of shipments. It could be demand. It could be anything. So it's just an abstract number. So even if it's, yeah, it is called weight, but it is not in relation to directly to the weight of the shipment. If you want to, you can use here number of shipments, whatever you would prefer. So this is how I answered it. Hopefully you guys answered it the same way. Otherwise, feel free to correct me. Yeah.
Perfect. Then there was also the topic, which kind of distance calculation method is used, was also answered. So this is B-line. That's the same for the both approaches. I think that's fine.
Just careful, B-line in the center of gravity. In the transport optimization, we are using actually street level distances.
Yes.
Yeah. But in center of gravity, it's the B-line approach. Yeah.
And last but not least, so there was the question, when should I use the old version and when the new version of the center of gravity? So that's perhaps a difficult question, to be honest, right? So which one is better?
Yeah.
But perhaps Alex, you can also just comment on that.
So I think if you really optimize it based on the numbers, what I showed you, I would always use the on version that we had in the whole time, right? The main reason why we did it in the classical way, how it's taught at university, then our result can actually differ, right? Because we have this additional optimization step in there. There is sometimes the topic, if you want to have it just fully logical visually, then it sometimes makes sense to turn this feature off, right?
No.
But if you really want to, but overall, center of gravity anyways gives you a starting point in the network design, right? It will be in a network design study, it gives you an idea where a center could be. Then in the second step, you would anyways make a concrete selection of warehouses, of concrete locations, and so on. Yeah, therefore, I would say I would use the one with the on feature because it's in an additional step more optimized. But if you have some visually some not that logical result, then I would turn it off.
Good.
Perfect.
Yes, I think so. So far, then we have it regarding the questions. Let's continue, Alex.
Okay, perfect. Then we can come back to our last item of today, the drag and drop and the subfolders in the workspace area. So this was an item we got multiple times as a feedback from you guys. If there is a possibility that we can make this a bit more user-friendly, let me quickly go to the platform and let's hope that I created enough demo data to show you this. So here I have my workspaces. I also have the search, for example, of the workspaces to organize this area here. But what is actually now new is the following. So the folders we had already. If we take this feature on save scenario, then as you remember, I made a standard center of gravity calculation. Here I have the dashboard, the map, the input, output data grouped already under this scenario name. Then one calculation was called off, the other on, and so on. And then I did in the end the transport optimization plus. So now if you have a bigger project, and what we also saw with multiple customers, it can happen that you have hundreds of items here on this level, and then it's really difficult to organize. And we saw many customers that create then multiple workspaces, but then they have to share the workspaces again differently. And now we just introduced that you can have actually subfolders and folders. So let's quickly create here on top of folder. So by the way, this is just now the main project. We could have already folders before. This is nothing new. what we can actually do now, we can just take this with a drag and drop and pack this in the folders, like your standard feature, like you are used from any Explorer in Windows or on Mac. So now when we go here in, this is in there. You also have additionally the possibility to create now directly subfolders. So then we can, for example, say COG. I think hopefully it is clear what I mean, that you can just create as many subfolder structure as you want. And we did COG and then we did route optimization. Now I have in here the subfolders, and now let's pack the center of gravity. This on-off was also part of the center of gravity calculation. You can just pack this in here, and you can just nest now your project structure and have here the results. If you want to get something out on the highest level, because for example, this center of gravity map is really important. It should be here on this level. You can just drag it up, and then you have it also on the highest level again. Yeah. So here you can have also the possibility with drag and drop to move the items between the subfolder structure. And this is now also with this release published, and then you can actually organize the subfolder. So this is independent of the sharing. So I would still recommend you share everything here in front on the workspace if you give it to your customers, but you can just clean the topics better up. Also, if you want to prepare, if you have the input data and then the final results on the highest level for your customer, if you share the whole workspace, then hopefully this is now easier, this feature. Additionally, what we also have, we have here on top in front, I think I showed, I'm not sure if I showed it last time, otherwise I just show it again. We have also this select feature, this multiple select, that you can also easier manage the deletion of some topics. This is also in there. Yeah, this is actually the topic what I wanted to share regarding this new, this new organization of the workspace itself. Okay, perfect. So now I covered actually all the points what I wanted to share. Are there any additional questions in the round?
No, not so far, at least not in the Q&A section.
Okay, perfect. Then I think so, yeah, like mentioned already in the beginning, in February, we have a really big release, the Lockup 6.0. You will hear many topics already in the pre-release statements from our marketing. So we will have two new applications. We will have a new AI agent. We have a separate, also different pricing models. So many cool things to look forward, where we are already internally working. Until this is live, the only thing what I wanted to do, I wanted to wish you happy holidays and a nice holiday season. And I hope you have some time to relax. And then I'm really looking forward for 2026 with our new release Lockup 6.0. Then thank you very much for your time and have a great day. Thank you. Bye.
Bye.